Ahoy there! Here we are with differentiation, lesson number 7, stationary points and their nature. If you remember last lesson, we were looking at increasing and decreasing functions, and if you have a section of a graph that slopes up from left to right, for that section the function is increasing. If you have a section that slopes down from left to right, for that section the function would be decreasing. However, at stationary points the function is neither increasing nor decreasing. If you think about it though, how did you find if a function was increasing or decreasing? Well, you looked at the gradient. So if it's doing neither, it means the gradient's not positive and the gradient's not negative, so you would say that at a stationary point the gradient is just 0. I know. So if you think about this on a graph, say you take this funky graph here that's drawn badly in pink, you can see that the gradient just before point A is a negative and just after point A it is a positive. But there's that point A where it changes from negative to positive, and that gradient there is going to be 0. It's the same for this point B. Just before it's a positive gradient, just after it's a negative, but just at that point the gradient is going to be 0. You will be asked to work out the nature of a stationary point, and to do that what you want to do is you want to take the gradient just before and just after that point, so look at the gradient either side, and you will then find if it's like point A, a minimum turning point, or point B, a maximum turning point, or it could be like point C. And with point C you can see that it starts to level off, the gradient ends up at 0, but instead of going back up, the graph continues to go down, and for that it's known as a point of inflection. And points of inflection are something that you can look forward to next year. We look at them more in advanced higher. But just now, really the nature just means, do you have a minimum, do you have a maximum, or do you have a point of inflection, which could do one of two things. So really you do have 4 different options for your graph. You could have something like this, which is known as a minimum turning point. It's the lowest point here, and that is when the function changes from decreasing to increasing. It could also change from increasing to decreasing, and that is known as a maximum turning point. Or you could have it looking something like this, where it goes from increasing to, well, it's not going to decreasing, it just starts to increase again, and that's known as a rising point of inflection. Or you could have it something like this, where it's known as a falling point of inflection. If you think about it, if you're given f of x, well, since stationary points have a 0 gradient, it means the derivative f dash x is going to be equal to 0 at stationary points. And one phrase that you need to remember is stationary points occur when dy by dx equals 0. That is something that you always need to write down and you always need to remember. So how do you work out the stationary point then? How would you work it out if you were given a function? If I gave you y equals something in terms of x, how do you go about getting it? Well, what you want to do is you, first of all, you want to differentiate your function and you set it equal to 0, because you know stationary points occur when dy by dx equals 0. You would then solve that to find x. You want to find the x value that makes the derivative equal to 0. You will then use what's known as a nature table, which I'll show you in a second, to find out if it's a maximum or a minimum or a point of inflection, and then you'll know if it's a maximum minimum, you'll know the x value, but to get the y value you sub x into the original equation to find out what y will be. Now your nature table, it looks something like this. Woo! And I'll show you this through an example, and I'll talk you through it. So let's go into example number 1. Find the stationary point or points on the curve y equals 2x squared minus 12x plus 7 and determine the nature. So for this, the first thing you want to do to get a stationary point is differentiate. X is not in the bottom of a fraction, there's no square roots, so we can differentiate to get dy by dx. If you differentiate that, you'll end up with 4x minus 12. How do you know when you get a stationary point though? Well, the big yellow box on the last page that you'd have to remember is stationary points occur when dy by dx equals 0. You have to remember that. From there, you would set dy by dx equal to 0. So 4x minus 12 equals 0. And then, step 2, you can solve to find x. So that's just from the last page. We've got our function, we differentiate, we set it equal to 0. From there, add 12 to both sides, divide by 4, and x would be equal to 3. So that's us solved to find x. Step 3 was the nature table. And the nature table lets us know if this is a maximum or a minimum by considering a point just before and just after this x value. So your nature table, what you do at the top line, you put in 3 and you pick a point just before that and a point just after that. You want to go very close to 3, so you normally just go out by 1. Sometimes you can't do that and you'll have to go out by a smaller decimal, but normally going out by 1 will be absolutely fine. You then want to sub the values in to dy by dx. Remember, dy by dx gives you the gradient, it's the derivative. So pick a point just before 3, so a point leading up to 3, such as 2, and sub that into dy by dx. So this is dy by dx here. If you sub in 2, it'd be 4 times 2, which is 8. Take away 12, which is negative 4. We're not interested in the number. All we want to know is it a positive or a negative, and it's a negative. We know then that just before 3, since it's a negative, the graph will be sloping down the way. So it's sloping down from left to right, which is what that's showing. If we sub 3 in to dy by dx, well, you've probably already guessed this, but 4 times 3 gives you 12. Take away 12 and you get 0. You should always, always, always get 0 when you sub in that number that you found, because what you're really doing is you're finding the number that sets dy by dx equal to 0. So if you don't get that, you've made a mistake. If you get it 0, I'm just going to show that with a horizontal line. After that, pick a point just after 3, go for 4, and sub that into dy by dx. So 4 times 4 is 16, take away 12 gives you 4. Again, you're not interested in the number, it's just is it positive or negative, and that is a positive. Which means then the slope is that the graph would slope up. So the graph's going up. What that shows you is that just before 3 the graph slopes down, just after it slopes up, which means then that that's going to be a minimum turning point. So we know our x value, we know it's a minimum turning point, but we can't find the actual point itself because we don't know the y coordinate. Mary Lou, what would you do? Well done, you can use substitution. We know x, so we can sub x into the original equation, this one here, and that'll tell us what y is. So we would do 2 times 3 squared, take away 12 times 3, plus 7. So working that out, when x is 3, we'll end up with y is 18, take away 36, plus 7, which gives us negative 11. Therefore, our point is going to be 3, negative 11. Make sure whenever you answer these questions though, you'll state, is it a maximum, is it a minimum, is it a point of inflection? And for that, our nature table shows us it's a minimum, therefore you've got a minimum stationary point at 3, negative 11. Let's try a second example, number 2. For this one, find the stationary point or points on the curve y equals 2x cubed minus 6x and determine the nature. And there's also a part B, when x is 5, is the function increasing or decreasing. So for this question here, starting off with y equals, and we want to differentiate. So dy by dx would equal 6x squared minus 6. After that, how do you find the stationary point? Well, remember, stationary points occur when dy by dx equals 0. You have to remember that. Okay, write that down. That's why I'm putting it in a yellow box. It's very, very important. After that, set the derivative equal to 0. So 6x squared minus 6 equals 0. And solve that to find x. Now to solve this, what you can do is you could factorise. There's a 6 here and a 6 here, so take out 6 as the highest common factor. From there, you've got x squared minus 1. What's that you're shouting, Muzamil? Difference of two squares? You're perfectly right. You've got x squared minus 1, they're both squares. It's a difference, it's a minus, so you could split it up again. You can factorise it. So you have 6 times x plus 1 and then x minus 1. Solving that to find x, If x plus 1 equals 0, x would equal negative 1. And if x minus 1 was equal to 0, x would equal 1. So we've got two values of x that will make our derivative equal to 0, which means then we will need two nature tables. Do not put them into the same nature table, make sure you put them into two separate ones. So with our first nature table, I'm going for negative 1. Set it up just the same way, pick a number just before negative 1, a number just after, sub it into dy by dx, and then think about the slope. Is it increasing, is it decreasing, or is it going to be just a horizontal line? Just indicate that when it's a 0 gradient. So pick a point just before negative 1, such as negative 2, and sub that into dy by dx. Do not make the mistake of subbing into y. Okay, it's dy by dx that you're subbing it into. So you would have 6 times negative 2 squared, take away 6, work out if that is a positive or a negative. If you do that, you will end up with a positive number, so you can write down positive. Sub in negative 1, if you sub that in, negative 1 squared is 1 times 6 is 6, take away 6 gives you 0. Again, you should always get 0 for that. Sub in a number just above negative 1, such as 0. So replace x with 0, 6 times 0 squared is 0, take away 6 is obviously a negative. Which means then that the graph is going to be increasing, then it's going to be at a 0 gradient, and then it'll be decreasing, meaning that will be a maximum turning point. Do the same thing for 1, sub in a point just before 1 and a point just after 1. You could again sub in 0, so if you put in 0, again, you did it there, and you got a negative. If you sub in 1, 6 times 1, take away 6 is 0, and if you put in a number bigger than 1, such as 2, you would have 2 squared times 6, take away 6, still gives you a positive. Therefore, the slope is going to be sloping down, then it'll turn and go up the way, meaning that will be a maximum, because the graph will look something like that. So that there will be the minimum turning point. Once you have done that, you know if it's a maximum, you know if it's a minimum for these points, but you need to know the y values. So again, you could sub them in. So doing that, this is just from the last page, you could say when x equals negative 1, and you can work out the y value. Remember, sub it into the original equation. Doing that, you will end up with 4, giving you the point negative 1, 4. Subbing in 1 to the original equation will give you 2 times 1 cubed, take away 6 times 1, which becomes 2 take away 6, giving you negative 4. And that point will therefore be 1, negative 4. Remember to finish off, always state the points if they are a maximum or a minimum or a point of inflection. So you can say for that, remember this negative 1, negative 1, 4 was a maximum. So there is a maximum stationary point at negative 1, 4 and a minimum stationary point at 1, negative 4. You can also check this is right by putting it into Desmos or putting it into Google. If you Google the equation, it shows you what the graph's like, so you can tell if you're right or wrong. Obviously, you can't do this in an exam, but you can when you're working through it. Part B was saying when x is 5, is the function increasing or decreasing? You can do this one of two ways. You know that when x is bigger than 1, you can see the graph is increasing. So you can say that we can see from the nature table that the function is increasing when x is bigger than 1. So when x is 5, the function will be increasing. What you can also do is you could sub 5 into the derivative. Remember, this is just from the last lesson with increasing, decreasing functions. If you sub 5 into the derivative, which was back a page here, if you sub 5 in, we would do 5 squared times by 6, take away 6, it's going to give you a large number, a large positive number, so you know it's going to be increasing. So you can do that one of two ways. One final example, number 3. A function is given by f of x equals 5x cubed minus 3x to the power of 5. Find the coordinates and nature of its stationary points. So to start off with, you have f of x equals just what I said, and you differentiate. So f dash x equals Differentiating, 5 times 3 is 15, that would reduce to become x squared. Again, 5 times 3 is 15, and that become x to the power of 4. How do you know when it's going to be a stationary point? Well, stationary points occur when dy by dx equals 0. But in this case, you don't have y or dy by dx, you have f dash x. So you would say that. Make sure in an exam you do not write dy by dx, write f dash x. Go with whichever notation they give you. Set the derivative then equal to 0, so 15x squared minus 15x to the power of 4 equals 0. And again, solve that for x, so factorise both of these. You can take out 15 as a common factor from the terms, and you can also take out x squared. So 15x squared bracket x minus 1 minus x squared. From that, Mazamal, I see you waving again. What are you saying? Yeah, difference of 2 squares. Good. You're on fire, Mazamal. So 1 times 1 is 1, x times x is x squared, and there's a negative, there's a difference. So that is also difference of 2 squares. So you have 15x squared, 1 plus x, and then 1 minus x. If 15x squared was equal to 0, x must be 0. If 1 plus x equals 0, x must be negative 1. And if 1 minus x was equal to 0, x would equal 1. So we get 3 values this time, which means then, Mediha, how many nature tables do we need? 3! Yes, well done. 3 nature tables for this one. So you've got a negative 1, you've got 0, and you've got 1. Again, make sure you're writing f dash x, not dy by dx. So do the same thing. Pick a number before negative 1, such as negative 2, and sub that into f dash x, which is here. So if you sub in a number less than negative 1, such as negative 2, you will end up with a negative, meaning the line will slope down. If you sub in negative 1, you will get 0, just double check that. And if you sub in a number bigger than negative 1, do not, however, pick 0 this time, because if you pick 0, it's also a value that makes the derivative equal to 0. So pick something really close to negative 1, but not as much as 0. Don't go as far over as that. So pick something like negative 0.5 or negative 0.6, negative 0.7. Do that on a calculator, and if you do it, you do get a positive value. It's a positive number you get, meaning the graph will look something like that. So because it slopes down, then it's a 0 gradient, then slopes up, means you've got a minimum turning point. Do the same thing with 0. If you sub that into f dash x, a point just before will give you a positive. A number just after will also give you a positive, which means then that the line is sloping up. Then it's a 0 gradient, then it's sloping up again. So this time you don't have a minimum, you don't have a maximum, you would have a point of inflection. And do the same thing for 1. If you pick a point just before 1, but don't go for 0. Go for something like 0.8 or 0.9, 0.7, 0.5. If you put that in, you will end up with a positive. If you put in 1, just check that you do get 0. And if you end up putting a number bigger than 1, such as 2, if you put that in, you will end up with a negative, meaning the line graph will slope down. So because it slopes up, comes to 0 and then slopes down, that will be a maximum. From there then, you will know the maximum, the minimum, and the point of inflection. You know the x values, but you also have to work out the y values. And the y value is really just f of x. So that's from the last page. So now you can say when x equals negative 1 and work out what f of x will be. Subbing that into the original equation, just up here, you'd have 5 times negative 1 cubed, take away 3 times negative 1 to the power of 5, and that would give you negative 2, giving you then the point negative 1, negative 2. Do the same thing with 0 and 1. So when x is 0, f of x will equal 5 times 0 cubed, take away 3 times 0 to the power of 5, giving you just 0. Meaning the point then with an x and a y will be 0, 0. Do the same with 1. When you sub 1 in, you would have f of x is going to be 5 times 1 cubed, take away 3 times 1 to the power of 5, which will give you 2. Meaning that is the point 1, 2. After that, just finish it off and state each point individually and say, is it a maximum, is it a minimum, is it a point of inflection? And for this one, you can say there's a minimum at negative 1, negative 2. there is a point of inflection at 0, 0, and this one here with 1 was a maximum, so there is a maximum at 1, 2. This has been quite a long lesson, but hopefully you are understanding it. It is finding stationary points and their nature. Give the questions a shot in the book. Any problems, let me know. Good luck. Woo!